Welcome and welcome back. I'm Patrick, and today we're going to figure out how something this small can hold trillions of digits of information. Let's get started. Before we get into the specifics, we have to figure out what a digit of information is. In a computer, in the context that we're using it right now, it's either a 1 or a 0. This is called binary. Binary works like this. Over on the far right, you have the 1. Then there's 2s, 4s, 8s, 16s, and so on and so forth, doubling each time. This is the same way that our base 10 system works, but with base 2s. The reason that computers use this is because voltage can really only be on or off. It's fairly difficult to determine what the voltage is and turn that into a base 10. That's why high voltage means 1 and low voltage means 0. To write numbers in binary, you just figure out what they have. Whatever the biggest number that they have in it is. For example, if I'm doing 11, does it have a 16? No. Does it have an 8? Yes. So I can put a 1 in the 8 column. Okay, so 11 minus 8, that's 3. Does it have a 4? No. Does it have a 2? Yes. And does it have a 1 remaining? Yes. So 11 is 1011. Now that we have a basic concept of binary, we can explain why something like this or this holds so much data. Inside of this, there are billions of little gates that hold either an on or an off. This 1 or 0 is called a bit. It's 16 gigabytes, which means 16 million bytes. 8 bits equals 1 byte, so you do the math. They make them very, very small. These gates are very small. I know I said that already, and I'm going to say it again. They're very small. They're less than 1 square micron. They're almost less than half a square micron. To give you some scale, 1 micron is a millionth of a meter. A meter is 40-ish inches, 39 and change. And so if you divide that by 100, you get a centimeter, which is 100th of a meter. You divide that by 10, you get a millimeter, which is 1,000th of a meter. You get the idea. A millimeter is still pretty small. So they can pack a lot of these into something that's this size. The size of these is actually smaller than most bacteria, which means they can fit more than 1 trillion of these inside something this small, this micro SD card. To make this gate a 1, the floating gate is charged, and when it's a 0, it's not so much. To charge the floating gate, the drain and flow are grounded, and the control gate is charged with a lot of electrons. These electrons can flow through the insulating layers around the floating gate and into the floating gate. Then when this current stops, the floating gate retains the electrons. To drain it, it basically does the opposite. Negative voltage is applied to the control gate, while lots of voltage is applied to the drain and flow. Then, electrons flow from the floating gate through the insulator and to the drain. Although flash memory is very useful, it will wear out over time. Because the floating gate is insulated, the insulation will actually wear out as the electrons pass through it. SD cards or USB drives can only be written and rewritten a certain number of times. Usually it's fairly large, but once you've exceeded this limit, it's not going to work anymore. If you want more stuff about computers and binary in general, or maybe a follow-up video on binary, leave a comment down below. If you enjoyed the video or want more content, want to be notified of more content, then you can subscribe right here. If you want more videos just right now, then you can click one of those here or here. Thanks for watching.